Good afternoon, and welcome to NASA headquarters. I'm Mira Bernstein in the Office of Communications. Thank you for joining us today for an update on NASA's Artemis campaign. To give you an update, we have NASA Administrator Bill Nelson, NASA Deputy Administrator Pam Melroy, Associate Administrator Jim Free, Reid Wiseman, NASA astronaut and Artemis II commander, NASA's Flight Operations Directorate, and joining us virtually, Amit Kshatriya, Deputy Associate Administrator, Moon to Mars Program Office, Exploration Systems Development Mission Directorate. Kathy Koerner is unfortunately unable to join due to losing her voice. We'll be taking questions from those in the room and over the phone. As a reminder, you can press *1 to get into the queue. But first, I'd like to turn it over to Administrator Nelson for opening remarks.
We are here to give you an update on Artemis. If you recall back when we first went to the moon, President Kennedy went to Rice Stadium, and he gave one of the most memorable speeches of his presidency. He said, "We go to the moon and do other things, not because it's easy, but because it's hard. Space is hard. And the endeavor, like Artemis, over a half a century after Apollo, is hard. It's the pinnacle of new possibilities. It's the most daring, technologically challenging, collaborative, international endeavor that humanity has ever set out to do. And the Artemis I test flight was just that. It was a flight test on a new spacecraft and new technology. During Artemis I, the heat shield performed in unexpected ways. And since then, we've been studying the data to determine the best path forward. We've done extensive testing to understand the risk that our astronauts will have while accomplishing the goals of landing back on the moon, bringing them home safely, and this will be the first time in over a half century. We've conducted expansive testing, including analyzing samples from the heat shield. We were able to recreate the problem here on Earth, and now we know the root cause. And this has allowed us to devise a path forward, which we are going to share with you today. Now, just this morning, we have concluded the Executive Council. This was after we had an independent review team. We had the deputies meeting. We had their agency bosses meeting. All of them made a unanimous recommendation to the Executive Council, of which it's my responsibility as the chairman to accept or not those recommendations. And based on the data, we have decided, NASA unanimously, in our decision makers, to move forward with the current Artemis II Orion capsule and heat shield with a modified entry trajectory. Later on, they'll get into the specifics of how you modify the entry so that you lessen the heat coming back into the Earth's atmosphere. Additionally, we need to complete our updates to the Orion environmental controls and the life support systems that were identified earlier this year. And that's a very important part. The ECLIS system, the life support system of Artemis II, needs to be checked out. That's a very important goal and accomplishment before we go translunar injection to the moon. And so we are planning for Artemis II to launch in 2030. We need to get this test flight right. this Artemis II test flight right to ensure the success of our return to the moon and then return safely to Earth in order for the rest of the Artemis campaign to proceed. We've made tremendous progress on the Artemis campaign, including establishing the Moon to Mars program, defining strategies and objectives through our regular architecture concept reviews, launching and learning from the first test flight, Artemis I, developing our suits, the spacesuits that our astronauts will wear on the surface of the moon, and awarding 2 contracts to develop human lander systems. Space is demanding, and we and our industry and international partners need this time to make sure that the Orion capsule is ready to safely deliver our astronauts to deep space and back to Earth. We need our commercial and international partners to double down to meet and improve this schedule. And that's why I personally have met with the company executives, including the CEOs from the following: SpaceX and Blue Origin on their landers, and I've met with them personally. Boeing on the SLS, Lockheed Martin on Orion, and Axiom on the spacesuits. And I have showed up with many of these leaders, sometimes unannounced, to our and their manufacturing and assembly sites. We also routinely engage with our international partners, especially ESA, the European Space Agency, which supplies the European Service Module, including we have on several occasions visited their facilities abroad. And we must have a shared sense of urgency among all these partners, and I think we have that. As I said, the Chinese government has announced their intention to land on 2030. It may be earlier. They're not planning to land humans on the vital portions that we're going to land, the lunar South Pole, and it is vital for us to land on the South Pole so that we do not cede portions of that lunar South Pole to the Chinese. We've made significant progress on the Artemis campaign over the last 4 years. We created the Moon to Mars program. We've commissioned the 2 lunar landing systems, SpaceX Starship and Blue Origin's Blue Moon, to deliver our astronauts to the surface of the moon. We commissioned Axiom Space to develop the next generation of spacesuits. We simulated the international partnerships and agreements for key Artemis elements, including with the UAE for the Gateway Airlock Module, and with Japan to provide a pressurized rover for the lunar surface. We flew Artemis I around the moon. Artemis I is the first time that we've sent a human-capable spacecraft to the moon since the Apollo days. And we are now, as we speak, stacking the solid rocket boosters, and then comes the Artemis II core stage, which is in the VAB, the Vehicle Assembly Building, as we speak. We'll stack that and the launch vehicle stage adapter. All of this is going on for this next step, the crewed flight test. The safety of our astronauts is always first in our decisions. It is our North Star. We do not fly until we are ready. We do not fly until we are confident that we have made the flight as safe as possible for the humans on board. We need to do this next test flight, and we need to do it right. And that's how the Artemis campaign proceeds. I want to thank all the teams for all of their hard work, and it's been extensive. And now I want to turn it over to our great Deputy Administrator Pam Melroy. Colonel Melroy.
Thank you, sir. Thank you. I'd also like to express gratitude for all of you who are here or online for your time today and your continued interest in Artemis and the space program. At its very core, NASA is a learning organization. The knowledge we gain builds mission by mission, allowing us to stretch further, farther, and accomplish more. In the test campaign of Artemis, this is the exemplification of that learning. Each test mission, you must examine very closely what you've learned and feed it forward so that we can advance with greater knowledge and less risk. So one area that's taken us a considerable amount of time to learn from Artemis I is how the heat shield performed during the mission. Obviously, a very critical aspect of the mission. After Artemis I, we noticed that there was a variation across the appearance of the Apollo heat shield, where the material that coats the capsule at the bottom, that protects the capsule during the heat of reentry, it wore away differently than we expected. We have models for this sort of thing, so we took that very seriously. First, I need to introduce a concept called a skip entry. This is a technique we use coming back from the moon because the velocity of the spacecraft and the energy that it has to dissipate is much greater than the energy that you dissipate just coming back from low Earth orbit. So the way it's designed is to dip in and out of the atmosphere to reduce the velocity. We have since determined that while the capsule was dipping in and out of the atmosphere as part of that planned skip entry, heat accumulated inside the heat shield's outer layer, leading to gases forming and becoming trapped inside the heat shield. This caused internal pressure to build up and led to cracking and uneven shedding of that outer layer. This root cause investigation began almost immediately after our observations, and our team has been pretty relentless in focusing on every possible root cause. I have a lot of gratitude to the team that worked on this inside the agency for their rigor, for their thoughtfulness, and their thoroughness. We really did not want to drive that team towards a specific deadline. They know the urgency as well as anyone else of continuing the Artemis campaign. So instead, we didn't give them a timeline. We gave them the resources that they needed to thoroughly investigate this and come back with the root cause. We had to understand why that erosion variation in the heat shield occurred to make sure that our astronauts would be safe during Artemis II. Just want to say that's how it's done at NASA. We expect the highest standard for technical excellence. We want to understand first the root cause, then we want to test and model so that we can bound the risk, and then and only then do we develop flight rationale for why it's safe to go fly when we have bounded the risk. That's exactly what we did. I also have to give tremendous kudos and thanks to Paul Hill, who led our independent review team. They were absolutely brilliant. Paul's team provided us with a lot of thoughtful analysis and independent perspective, and they ultimately concluded that our team did identify the correct root cause of the Artemis heat shield issue. They also validated that our test approach would bound the risk that again ultimately led to the flight rationale that it was safe to fly. As we're looking ahead, we know we're going to learn a lot more on Artemis II, and we remain committed to that learning and to the rigorous process that we have always adhered to keep our crews safe. Thank you again for your time and your continued interest in Artemis and the space program. Now I'll turn it over to our Associate Administrator, Jim Free.
Thanks, Pam. Good afternoon, everyone. Thanks so much for taking the time to be here and for really taking time to understand how we got to where we are today. And I think you all know, but our campaign of human exploration, science, and discovery that began with Artemis I continues with journeys to the moon and then journeys on to Mars. Our vision extends into the next decade to establish a long-term presence at the moon, a presence that we can sustain to explore more of the moon than ever before. And the reasons we go begin with improving life on Earth and understanding our place in the universe, as we've shared in our Moon to Mars objectives. We are at the next step of our roadmap. Artemis I was the first, and we are on our way. The beginning of that roadmap, as we said with Artemis I, is a series of test flights where we will learn. We have and will undoubtedly meet many challenges along the journey, and the choices we make at each inflection point inform the path from there. It's important at each of those decision points that we reaffirm our vision and our values. And today, as you've heard from the administrator and the deputy administrator, is one of those points. We've reaffirmed our commitment to extend humanity farther into the solar system with Artemis, and we've honored our core values in the process that begin first with safety. Our decision has been made first around safety on the heat shield, as we understand and mitigate the risks that come with spaceflight. Knowing what we know now, it also proves how important it is to maintain the continuity of NASA's industrial base and sustain a regular flight cadence to ensure the expertise and critical information remain ingrained in our collective knowledge. It builds on what you heard earlier on the diversity and the resilience of our solution. In addition to sustaining manufacturing capabilities and supply chain, we must all do everything in our power to honor our schedule commitments that are codified in the contracts that we have with all of our suppliers for each Artemis mission. A regular flight cadence not only helps us to avoid repeating past challenges, but also helps us to advance the goals of Artemis with greater efficiency and foresight to ensure we remain a global leader in science and exploration for the benefit of all. These technical challenges, be it the heat shield or others that you'll hear from Amit, are difficult, and we learn through tests on the ground and in flight. That will continue as we push the limits of exploration and our destination and the complexity of those missions. The challenges are also solved at a rate that is measured by safety and measured by delivery of hardware from our contractors and partners. The team we have, both NASA and contractor, is incredible. That's evidenced to me by our performance on Artemis I, the disposition of the heat shield, and all the development that is going on across the country and, frankly, across the world. And I am grateful for each one of those folks. With that, let me turn it over to the commander of the Artemis II mission, Reid Wiseman.
Thanks, Jim. For those of you who are just sitting here, I want you all to know we like to keep our associate administrator well flanked by astronauts, and I think we've done a good job today. I'm the lucky one who gets to be here, but I am definitely speaking for our crew, for Victor, Christina, Jeremy, our two backups, Jenny Gibbons from the Canadian Space Agency and Andre Douglas from NASA. First and foremost, I want to thank the media for being here. This is the great part of our nation, is that you all get to talk to us and get to think and freedom of speech and get to report on the state of our program. Thanks for your interest in Artemis, and thanks for getting the word out to the general public. We really do appreciate the efforts. I also want to thank the NASA leadership team. I'll echo what Pam was saying, was sometimes in space, delays are agonizing and slowing down is agonizing, and it's not what we like to do. But from the crew perspective, the thing that we most asked our leadership for after Artemis I was root cause of the ablation of the heat shield. And we took the time. This was very, very open process The crew certainly never felt like there was a door closed to us. We never saw any hidden data. It was all open. It was all open discussion. We had an independent review team with a lot of outside experts and internal experts to look at this. So we really appreciate the willingness to take the risk to actually slow down and understand root cause, determine the path forward, corrective action for Artemis II and Artemis III, so that when Victor, Christina, Jeremy, and I launch and land after a successful Artemis II, we will look to Artemis III to carry the torch forward and to put humans back on the moon, and that is really our ultimate objective. Quick story time before I hand it over to Amit. The folks in the room that don't get to get out the way the crew gets to get out. In November, I was at Kennedy Space Center with our crew, all four of us. It was Victor, Christina, Jeremy, and myself. And we were in the vehicle assembly building, and just when you walk into that building and see the boosters, see the core stage, see the American men and women that are putting this vehicle together, the excitement that is in there, the scale, it is absolutely inspiring just to see the scale of what is going on. The thing that we walked away from was the sense that, you know, we are in simulators all the time. We see PowerPoint slides, there's meetings all the time at NASA, but we started to feel this is absolutely real, and it is awesome. While we were there, we were in the airport in Orlando coming home, and Jeremy Hansen, our Canadian astronaut on the crew, pulled out his cell phone, and we watched Starship 6 test flight from Boca Chica. And it was in that moment for me, as a kid who was born after Apollo, that moment in the Orlando airport, I had just seen our booster. I had just seen the Orion spacecraft. I'm now watching Starship 6 test flight. All the elements are there for humans on the moon, and all the elements are there to push us onto Mars in the very near future. And I felt it in my soul. I felt it and I believed it. And I want to thank our administration. I want to thank our workforce, because they are the ones that are making it happen, and the public who are supporting us. So thank you. With that, I'll hand it over to Amit.
So Amit will be on the screens for those in the room. Just give us a second.
Hello, everyone. Just quickly, can you all hear me okay?
Yep, we can hear you, Amit.
Some technical difficulties here. Okay, thank you. Let's see, I can't top Tano. I'm going to just start with an outline of what I'm going to talk about. I'm going to explain the approach that we're taking as part of the program office, detail the findings related to the heat shield, talk through some of the other issues that are affecting the performance of the integration at KSC, and talk about where we're headed. Congress authorized the Moon to Mars Program Office about 18 months ago. Since then, we've had the advantage to actually think about the risk of the integrated program from a mission basis, not just from the capability basis, and that's essential to ensure that we're on a safe path towards long-term exploration. And it also helps us guarantee that the 6 programs under the office, Gateway, HLS, the Human Landing System, EVA and Surface Mobility, the Space Launch System, Orion, as well as the Exploration Ground Systems program are integrated, are looking downfield together, and are trying to proceed in a rigorous test-based approach towards achieving mission objectives. This has been a really exciting time for these teams to come together, and what we do know is that our assessments have led us to an understanding that our current baseline plan has testing gaps. It needs to be augmented. Each mission needs to be augmented, and we need to think about each one to make sure that we're making the right progress. It is very easy for that pressure to change your perception, your engineering judgment, your understanding of technical truth. And so this is a little bit why we've been careful about discussing this topic. But let's talk about what we saw in Artemis I. As was mentioned, we for the first time conducted a skip re-entry of a heat shield that's 16 feet in diameter. It interfaced with the atmosphere at 32 times the speed of sound. It endured atmospheric entry, heating and velocities and aerothermal loads over 3,000 nautical miles of a downtrack, and it landed within 2 miles of the USS Portland. That was a phenomenal achievement. if you think about the specified design of the integrated system from an entry guidance and from a thermal load performance. However, as is mentioned before, we saw variations in the condition of the heat shield, in which the char layer that protects Orion broke off in ways we did not expect. We observed about 100 spots across the heat shield where that phenomenon occurred. Charring is normal ablator behavior during entry. The way that energy is dissipated, all of the energy we put into the spacecraft at launch has to be reduced so we have a safe and nominal landing. Most of that energy when we enter the atmosphere at that speed is rejected by the radiative shock that occurs in front of the vehicle as it's transiting through the atmosphere. Some of that is rejected via convection through the outer layer of the heat shield. It is normal behavior for the ablator that it's built on Orion to char. The heat shield however, is not designed to liberate those pieces of char. Instead, a char layer and an ablator is supposed to recede gradually so the underlying material insulates the spacecraft from the high heat flux we experience during entry. As I mentioned, the performance was excellent, but that char loss is outside of the design intent. Now, just because our bond line temperatures were within 4 factors of safety, just because our guidance was right down the middle, just because we had the right amount of virgin abcoat material left, it is tempting to believe that means the spacecraft performed the right thing and it performed it with margin. But everything we've learned in our history tells us that's not what margin means. We have to have an absolute technical understanding of the transport and liberation phenomena that led to that loss of char, and so that is why we took the level of steps that we did to analyze this issue. So the Orion program stood up Heat Shield Tiger team to determine root cause corrective actions and to start thinking about what that technical truth needs to be. That team was a multidisciplinary team of experts in TPS systems, aerothermodynamics, thermal testing analysis, stress analysis, material test, all across the board. And as we continued throughout the investigation, we brought in experts from the Department of Defense, the Department of Energy, across industries across the United States and even internationally to help us understand that we were doing the ablator behavior, because this is cutting edge technology in terms of the way we're exposing these environments to make sure that we were using the best of what the country could offer to analyze this. So what I'll say first of all is the Tiger team, which was commissioned again by the Orion program manager, Howard Hugh, deserves a lot of credit for the rigor he applied, was led by Luis Saucedo, who conducted what in my estimation in the 20 years I've been in the agency, is one of the most magnificent pieces of engineering analysis that I have been a part of. Their work was substantial, significant, and extremely impressive. They started with a fault tree assessment that led directly to enabling advances, not just in understanding of the interactions of the vehicle's material loss properties and its interaction with the aerothermal environment, but also invented and innovated new test and non-destructive evaluation techniques for us to be able to actually observe this phenomenon in real time in the arc jets and the upgrades to the arc jets that we created as part of this investigation. We also use facilities at Wright-Patterson Air Force Base and all over the country to help us analyze this phenomenon. So again, I commend the team for their work, but again, because we're NASA, we wanted to make sure we're close to the problem, that we were being extremely rigorous. We brought an independent team of experts in, as Pam mentioned, led by Paul Hill, who did a phenomenal job. He brought in experts from industry, from the Department of Energy, all over the country to also give us confidence that we were doing the right things. Paul right now serves as a key member of the Aerospace Safety Advisory Panel. And of course, as those of you that know, he also led the agency's return to flight efforts after the Columbia accident. So the team provided us analysis, and again, the concurrence on the root cause is unanimous. So fundamentally, just as Pam said, the issue is that during reentry, as I mentioned, the ablative material has to produce those gases under pyrolysis, and pyrolysis is just burning without oxygen. We learned that as part of that reaction, the permeability of the abcoat material is essential. And this is something that did not necessarily produce itself in our reconstruction of the data until we looked at the regions where the recession of that char layer what was arrested, and that the recession was arrested during the dwell time during the skip reentry. During that period, the production of those gases was higher than the permeability could tolerate, and so as a result, a pressure differential was created. That pressure led to cracks in plane with the outer mold line of the vehicle, and as in certain areas of the vehicle where those cracks propagated to the bond line of the blocks, the char was then liberated. We were able to determine this correlation and connection between that permeability, because actually during Artemis I, it turns out that some small percentage of forward, as is pretty clear. We know because of the test program that we went in, that we executed. We know how to produce Abcoat with the desired permeability standards. We have sized up all of our production capability in order to quickly produce heat shields as fast as we can. In fact, we have 50% improvement in that production rate. But it's still going to take us a little bit of time to finish the qualification of that material. That should be ready to go here sometime this year. But where we sit today, we understand, because we understand very fully not only the interaction of the material and the environment, but also the integrated interaction and how it performs in the spacecraft. So we've decided that in order to enhance our learning for Artemis II as quickly as we can, because there's nothing like flying in the flight environment to learn everything that you need to learn about how these systems will perform, that if we can either change the material to mitigate the issue, or we can change the environment to mitigate the issue. And for Artemis II, because of the nature of the mission, which right now the mode we're using is equatorial free return, we can safely and with high degrees of success control that entry environment. And so that's the plan we're going to proceed along. Just quickly, we can talk if there's more questions. We're going to push out to everybody a detailed write-up of this understanding. But I do want to talk a little bit about what this means for us in terms of the execution of the mission. Of course, it's going to take us a little bit of time to go through the disposition of some of these issues. We are also experiencing a handful of issues in the performance and integration of the vehicle. We have, as I mentioned to this community back at the beginning of the year, we have had some issues with the electrical system on the vehicle, specifically when the vehicle is enduring an abort scenario. In some of those cases, in this particular case for Artemis II, the abort system on the spacecraft is active. So we need to make sure that the vehicle will have maximum capacity during those abort scenarios. We found an issue with the batteries in particular, that they were not able to tolerate the abort environment. It's pretty severe, especially when you do an abort induced by the launch abort system. So we had to fix those batteries. And we've been working on that fix for a while. We were able to completely change the way that they're mounted, that they're mechanically secured, and we have been able to complete that fix, qualify that fix. It was excellent work by the team at Eagle Pitcher in Joplin, Missouri that did that for us. It was also it was difficult for them to do it because, as was mentioned earlier, our supply chains in some of these critical areas are extremely fragile, and so we had some difficulty finding very high reliability components and in order to complete that build. But the team there was excellent, and Eagle Pitcher has a long history with us. In fact, those of you that recall, the Eagle Pitcher built the batteries that were allowed the Apollo 13 crew to be able to survive during their transit when we lost the fuel cells in that mission. The other thing we've been working on significantly is the life support system on the spacecraft. We are in the ONC at Kennedy in the Operations Checkout Center. We are conducting a full set of integrated life support system tests on the spacecraft. We are learning every day about how that system performs. We have got to make sure that every part of that is in the right configuration before we commit the crew to launch. You recall at the early part of the year, we discovered an issue with the control system of the valves in particular the carbon dioxide removal system. That anomaly has been resolved. We've also witnessed a few issues with the deformation of the seat material on those valves, which has caused overboard leakage. That has also been resolved. We've also been doing performance testing of the sorbent in that system to make sure it's going to have the capacity in all the cases that we care about, including multiple failure cases. So we're continuing to characterize and learn and test that life support system, but it is taking us a longer than we thought. And so we need to get that done. And we're making excellent progress there to the point at which now we're ready, as we said, to commit to stacking. So going forward, that additional time that we have that we need to get the vehicle ready and to get the stack moving, we're going to take that time to consider how to make the mission more robust. We have a lot of options to do that. It is a very large step between circumlunar free return and then the next mission, which we are going to exploit the amazing capability that Starship provides us. We believe that we need to pull some of those objectives forward. We're going to work with our industry partners to do that in order to make sure that by the time we're ready to fly Artemis II in the spring of 2026, that we're not only able to knock out the objectives that we had baselined, but also bring some forward from the landing mission, so that when we commit to that mission, we think it's going to be successful. So that's where we are. I want to just quickly talk about some of the other progress we've been making. This year has been extremely busy processing the spacecraft, but we have also had a number of other achievements that are worthy of note. In addition to the aggregation of the hardware of the Cape, we've made incredible progress in some of our lunar systems in terms of acquisition. We have added 3 providers to build lunar terrain vehicles. We have made historic international agreements with Japan and with the United Arab Emirates to add elements to the lunar surface architecture as well as to the cislunar architecture. That one of the great things about the ability that we have to take advantage of the incredible human spaceflight programs we have in place today, in particular the International Space Station, is our ability to advance and curate and expand the amazing partnership that we developed in low Earth orbit. And one of the reasons I can't be in the room today and I'm dealing with these audio issues is that I'm actually in Germany. We have the privilege of taking over. NASA has the privilege of taking over the chairmanship of the International Space Exploration Coordination Group, which is a consortium of 27 nations that have common interest in exploration. NASA having that leadership role is again just a testament to how inspirational Artemis is and what it means for the entire for the world to have American leadership in this area. So, across America, across the world, there are tens of thousands of people, as Tano said very eloquently, that have hands on the hardware, that are committed not only to making sure that we maintain our leadership role, that we lead with our values, that we lead in exploration with the norms and standards that we believe, the norms and standards that come from living in free and open societies, exploiting the innovation that occurs only in those open societies, and exploiting the incredible capacity and manufacturing capacity that exists in this country and needs to be expanded. That is what we are also trying to do with this program, and I think we're doing everything we can to lead with that inspiration. And so I'm very excited to hand it back to the team over there, but then also I look forward to speaking with you all again. Thank you very much.
Thank you, Amit. So now we'll move into the question and answer portion of our event. We'll open it up again to folks here in the room, as well as to those on the phone. If you're on the phone, please press *1 to get into the queue. When we call on you, please clearly state your name, outlet, which of our participants you're addressing your question, and limit yourself to one question, please, so we can get to as many people as possible. So I'll start here in the room. Yeah, we'll go to Micah first. We have a mic for you. Just wait 1 second. Thanks.
Hey, good afternoon, everybody. Micah Maidenberg, Wall Street Journal. Administrator Nelson or anybody else, have you shared kind of the new plan and schedule with anybody from the Trump transition team or its nominee to run NASA? And how confident are you that what you've just articulated will carry through to the next group, the next administration? Thanks.
Well, I've had, since the Executive Council meeting this morning, which went for 2 hours, I have talked to several people on the Hill. I spoke to Jared Isaacman yesterday and look forward to having a meeting with him, invited him to come, but because it was yesterday, I haven't told him what happened just an hour or so ago. But next on my list to call, which I simply didn't have time to call, is Gwen Shotwell, and then some of the folks in Blue Origin, and we'll get on down the list as time provides. If your question is, what do I think about the future of NASA under, it's not your question.
How confident are you what you just laid out with carryover?
I think the fact that we have gone so laboriously and we think made the right and safe decision, it will allow Artemis II to be launched in a very timely fashion. The flip side of that, had the testing not gone well and we had decided otherwise, that you had to rip off the space heat shield, that would have caused a considerable delay. So in answer to your specific question, I think it will be received very well by the new regime.
We'll go down in front here.
Hi, Ken Chan, New York Times. I guess this is a question for mostly Amit. Want to understand the heat shield core root cause. So if the avcode is sufficiently permeable, the gases don't build up and everything's okay. I'm sort of wondering what went wrong. Were the specs for the avcode correct and it wasn't produced and applied correctly, or was there not sufficient understanding of how the heat was going to build up during this skip maneuver?
Okay, just again to confirm, you guys can hear me okay?
Yep, we can hear you.
Okay, yeah, I think the question was, what went wrong with our understanding of I didn't quite hear you.
The question was there a problem with the avcode, the production and the application of the avcode? Or did you not have the right specs for the permeability or the understanding of how the heat would build up during the skip reentry?
Okay, yeah, okay, thanks, I get it, Ken, thanks. So a couple things. First was, when we moved, we've used the avcode formulation over the years. The spec was generated during Apollo. The Apollo spec was different. It had some environmentally sensitive materials that we can't use anymore. And that specification was handed over from multiple companies, from Avco to Textron to Lockheed Martin, and then into the Orion program. It also was flowed into the Constellation program, and then when it was shut down, a lot of that knowledge was lost too. And so there was a lot of kind of dissolution of the understanding of how to formulate the material. Also, the material subtly changed. So the other thing that happened was we changed the geometry of the Avco block, and so there was a lot of little, kind of links in the error chain that we call them, that accumulated over time that led to our inability to predict this in ground test. I think the biggest one was that when we were doing the testing, we were extremely focused on the block geometry and how the recession was going to work with the block geometry. We totally nailed that piece of it. We totally nailed the geometry layup, how it was all supposed to recess together. We also tested at the extremes of the envelope in terms of heating. But what we missed was this critical region in the middle, and we missed that region because we didn't have the test facilities to produce the low-level energies that occurred during skip and dwell. We assumed that at the low end and at the high end, if we had the testing and we had nominal performance and nominal, kind of off-gassing of the pyrolyzing gases, that we would have, that there would be no spallation. Since then, as I said in my summary, we've developed the capability in the facilities to simulate that dwell, and so it was a gap in our testing capability, as well as an erroneous assumption about what was bounding in terms of the test conditions that led to this issue.
Yeah, we'll go to Joey.
Hi, thanks. Joey Roulette with Reuters. Question for Bill. What led you to make this decision, or what led the agency to make this decision before the next administration comes in, considering the fact that they're likely to change many different parts of Artemis? And for Amit or Jim, what is the new trajectory, and why are you confident that's the way forward?
The answer to your first question is if we were going to be on this timeline, we had to stack. And as a matter of fact, we went ahead and even prior to this decision today, which has been informed over the last couple of weeks from the deputies meeting first, after the independent review team, and then the agency heads later, and now formalized with the Executive Council. We had already started the stack. These 2 solid rocket boosters are already lowered down and attached to the mobile launch platform. When that occurs, the life of the solid rocket boosters has a certain defined life. So we needed to get this thing going so we can stay on this timeline. And so I think that's the answer to your question.
Yeah, I'd just like to add, Joey, that to the greatest extent possible, we certainly want to defer any decisions about starting or ending programs. Major decisions need to be deferred for a new team, and we have not yet received a transition team, so we didn't have an opportunity to brief anybody. But I just want to emphasize, we're on a day-for-day slip. We had to make this decision. And if you're waiting for a new administrator to be confirmed and a team to come up to speed on all this technical work that we've all been tracking very closely, I think that would actually be far worse to defer it and hand a 5 to 6 month delay. It was pretty clear that we needed to go forward. So. And
Joey, just so you don't think that schedule is getting in the way of safety, at every investigation and determination on the safety of this as outlined with the changed reentry procedure, it has been unanimous. And so the poll today in the Executive Council, before I am required to make the decision, was again unanimous.
Yeah, Joey, I'll let Amit describe the 1,775 nautical mile trajectory.
Yeah, so a couple things on the entry trajectory. As Jim said, we want to constrain the downtrack, so the period at which the vehicle hits entry interface down into where aerothermal loading stopped at 1,775 nautical miles. I wanted 1,776 nautical miles because if we're going to fly in the early part of 26, we could have celebrated the 250th anniversary at the same time. That would have been elegant, but engineering said I couldn't do that. So that 1 extra mile is important because we didn't have data. So, but the reason why we know it's safe is because so a couple things. We had to move. There are 2 things that we really want to make sure we understand at Artemis II. One is, of course, controlling the environment here, but 2, we are doing the first ever crew extraction from Orion in the open water, and our sea states need to be as good as possible. So normally when we allow for the trajectory to occur over the Pacific, we allow for the vehicle to hit what we call a horizontal target line, which is where the vehicle intercepts the Earth's atmosphere, and essentially a wide swath of ranges over the Pacific. If we were to keep the horizontal target line where it was during Artemis I, the landing zone would have been well short of what we prefer to be optimal, which is off the coast of San Diego, which climatologically has the best sea states. So what we did is 2 things. First, we moved that horizontal target line such that downtrack now would put us in the preferred landing zone. And so that helps us in terms of confidence of our ability to do that. And of course, the Navy will do everything they can to make sure that's a safe operation. But the other part of it is reducing the skip duration, and our analysis of what that skip duration will do and the gas generation that occurs during that skip dwell is sufficiently low that we're not concerned that that environment for crack generation is going to overwhelm the structural stability of the char layer. And so that's based on tests. We've run those exact environments. We've run dispersions on those environments, and we've also run weather divert cases because we do have weather divert capability. The minimum guided entry capability we have is 1,300 nautical miles. Everything short of that is a ballistic entry. So we have basically 400 nautical miles of weather divert just in case on the way back we have seas that we don't like. I mean, circumlunar free return's a little different than coming back from orbit because we're essentially picking our landing time when we commit to translunar injection. So we have to get that right. And so we have all those parameters kind of collected together, which is where we got to that entry trajectory. And we think that's gonna mitigate all of those concerns.
I'm going to take some questions from the phone, and then we'll come back to the room. But first, Marcia Dunn from AP.
Yes, hi. I'm hoping you can hear me. How long would it have delayed if you had to have ripped off the heat shield and replaced it? And am I understanding correctly that there will be a new type of heat shield with the necessary modifications and repairs starting with Artemis 3 moving forward? Thanks.
The delay for Artemis 3 would have been from the existing plan of the mid-2027 to the end of 2028. That's Artemis 3.
Artemis 2 was a year. I believe Artemis 2 was about a year slip, maybe a little more, if we had to replace the heat shield.
And then the second part was, in our decision path too, we'll go with the existing, and all future heat shields will incorporate the changes that Amit has described for permeability.
We'll go to Gina Sinceri from ABC.
This question's for Reid. How does your training flow change with this new information, if at all?
Thanks for that question. It really allows us to just have focus now. We have a large decision behind us. A lot of the uncertainty has been removed, and we're wrapping things up on Orion. We were just, like I said, we were at the Cape in November looking at the spacecraft. It was in the vacuum chamber at the time, going through the environmental control life support testing. As that testing wraps up, I think from the crew perspective, we are really going to be digging in now into our integrated simulators. We've trained out most of our flight profile. We have not yet done ascent and entry training. We're waiting for the latest software load to do those training events in the Orion spacecraft. And once we get that done, we've hit all the core training fundamentals that we need. So for us, I would say in about 2 or 3 months, we'll really be able to start focusing on that last year prior to launch and getting all the day in the life activities complete. So it's just removal of that unknown with the heat shield now allows us to focus.
We'll go to Jackie Waddles from CNN.
Hi, folks. Thanks so much for doing this. So last time we had an update like this, I know the spacesuits and Starship were both listed as key projects that might hold up Artemis 3. I just wanted to circle back. Can you guys say whether those two projects are still part of what's driving the schedule for Artemis 3, or if you feel like they're more back on track? And then on that end, I'd love to just get an update on the agency's view of Starship's progress. And, as they're going into a critical design review next year, can you tell us a little bit about what that will entail and what NASA is hoping to see from the next few flights? Thanks so much.
Let's see. I'll start. All of our systems for Artemis 3 are driving the schedule. There are things we've learned on Artemis 3. Actually, some of the ECLIS stuff has informed Artemis 2. We'll learn from Artemis 2. The crew module will still be a driver. The service module's down in Florida. But I think what you heard from the administrator and Pam and myself is all of our contractors have to deliver to the milestones that we have in the contract. I'm going to let Amit give some details beyond what I'm talking here. But every launch to me of Starship is great because we need that launch to get to the next one. We have a critical milestone next year. Amit will talk about they still have to fly multiple times to do one of our missions. And that's critically important. They have to do the uncrewed demo, critically important. So for me, every launch is great, but each of those elements is important as well. Amit, you want to give some details on suits and prop transfer?
Yeah, thanks, Jim. The two major on the suit side, I guess Axiom's doing a great job. We've been to their factory recently. They have a great production line. You know, we have a pretty good command of the technology that's needed to make the suit work. It is a very difficult qualification problem and a manufacturing problem. You know, that's very tight geometry. The reliability standards that are levied on a suit like that is really challenging to meet. But you know, they have some of the best experts in the world. A lot of them came from the agency and are helping them internal, and also we have tremendous insight there. So they've got some challenges, I think, but you know, so far they've been very open with us about what they need, and we're working with them really well. But getting that life support system done, principally for the suit, and in particular, there are some very unique components, high pressure oxygen regulators, et cetera, that we're really struggling with. Again, I mentioned earlier that our supply chains are so fragile, and a lot of these, the specifications on some of these components are so rigid, and they're rigid for a reason, because of the reliability requirements that are needed. They're just hard to build, and we used to be able to build, a lot of different entities used to be able to build these types of components, and we are running out of industry that can do that, and so that's become a pacing item on that side. On Starship, as I said, again, you know, everyone's been following the incredible progress. You know, it is absolutely the capability we need to be able to exploit as soon as we can. We're really excited to fly with them. We would love to be able to do something even sooner than Artemis III to demonstrate that capability, but we need to make sure we work with them that's credible. Reuse is essential to them. They've made tremendous progress on reuse. To me, the propellant transfer flight is really the most important milestone. I think propellant transfer to me is as important in terms of learnings as we had with Artemis I. So, I consider that to be a major milestone in the program. Right now, they're on contract to do that here early in 2025. I know that they're working that really hard. There is going to be risks to that delivery, but when we can achieve that propellant transfer milestone, I think we'll have a lot of confidence as to how the rest of it is going to shake out. Of course, they do, as Jim said, have an uncrewed demonstration milestone in front of them as well, all the way down to the lunar surface. I mentioned to you earlier that as we started the program, one of the things that we did is we did a kind of integrated assessment of all the risks that in the baseline, and in that, even in the uncrewed demonstration milestone, SpaceX and NASA agreed to add a ascent demonstration from the lunar surface. We've never launched a liquid engine like that off the surface, certainly not one as powerful as Raptor. And, we have to make sure that we can condition the engine, get it chilled in the right way, and get it launched. And so that's going to be a huge milestone for us as well. But we're working really closely with them. Super excited. They're telling us everything they're doing. I think the next couple of flight tests, but their test program is moving, really fast, and they're making changes to how things are stacked up all the time. And so right now, our current understanding is in a couple of flights, they will migrate to a block upgrade of the ship, which will give the ship the endurance to stay in orbit longer. And once we have that, we should be able to achieve many more orbital tests, including prop transfer.
Hey, Amit, would you please share with them also the necessity of the desirability of proximity operations near the time of Artemis II's launch? Amit, could you hear me?
Yes, sir. I think you're asking about the importance of proximity operations. I really apologize. My setup here is not super functional, but yes, absolutely. So of course, if you think about the step between where we are today and what we have to achieve for Artemis III, the number of firsts that are on that mission. First of all, as I mentioned, the dual launch campaign. We have to get the two vehicles to meet at the same point. That's going to require incredible ground-to-ground integration, especially as we start taking access of the additional resources at the spaceport at KSC. That's going to be a big coordination challenge, and then having the launch control teams and all of that going together at the same time. That's just the start. That just gets us off the ground. After that, we have to be able to find each other in orbit. Proximity operations are critical. The integration capability. We're working really hard on building more facilities so we can do integrated software testing and ship-to-ship live sky testing between Orion and Starship. We're not there yet. So if we have to test it in space, we will. But we need to make sure that we have a really good and robust understanding of how to make sure we can navigate together, and then do proximity operations, share states, and of course we do have on the ground mechanical docking simulators on both sides. So we're pretty confident we can use that to make sure that we have the right fit up and the connections, because the vehicles will not meet. They will meet for the first time in space, but their docking adapters and their interfaces will meet before that to make sure we have that licked. But that whole integrated operation, all of us that watch Space Station and all the other operations that are like that, it's very, very sophisticated, and there's a lot of things that can go wrong. And so the sooner we can test that, even in simulated tests on the ground or with ground-to-ground test assets, the better. But the best test for us would be to get uphill. Both vehicles get uphill and fly by each other, maybe even fly together as soon as we can.
We'll come back to the room. Over in the corner.
Jeff Faust of Space News. Question probably for Amit. I recall with Artemis I, the certification for the boosters when their stacking started was a year. Looks like you're going more than a year if you're going to start stacking now for a launch in April 2026. What's the certification timeline for the boosters now? Have you stretched that out based on the experience with Artemis I?
Yeah, great question. So we, of course, the concern on the booster is a couple things. One is the cast life, which is from the time that the propellant was cast in Utah to when we believe the stability of the propellant is no longer suitable. That is. We know today that won't expire until early 2028, so that's not an issue. What you're referring to is what we call the stacked life. So what you get worried about right now, we have the aft assemblies hard down on the mobile launcher. Both of them in that configuration are stable. There's no stacked life clock that starts until we put the aft center boost segments on top of the aft assembly. At that point, now the theoretical concern is because of the compression on the seals and the interfaces, you could have propellant grains migrate from the inner liner and cause issues. Now the good thing is for stacked life extension, you can do that in real time incrementally over time, because what you can do is measure the slump in the booster to see if that propellant migration potential is there. If you don't see any slump, you get an automatic extension of the life. And for Artemis I, as you pointed out, we extended it well out past 12 months. We think pretty easily we can get to 18 months, generally just based on historical understanding. We started slump measurements just last week, so we knew that clock. So we have a good baseline for what that clock is going to be. And then even if we went longer, there are ways to mitigate that concern by controlling the launch temperature if we have to go there. Now, fortunately, our production on the booster side is also excellent. So if it turns out that we have a real issue, we would consider that potentially shipping the other boosters from the railhead in Utah and having those, but that would be an extensive kind of restacking operation. But we're not even close to that. I believe we can get between 18 and 24 months pretty comfortably.
Politico.
Hi, Sam Scove, Politico. This question is for Bill. You mentioned what almost sounded like snap inspections, right, of the various prime contractors that are involved. Sort of looking forward to the next administration, could you preview any of the advice you're going to give the next administrator on how to keep the program on budget and on time?
Well, I would not presume to share that here. I think we are handing to the new administration a safe and reliable way forward for us, which is to go back to the moon, to get there before China, to have presence in cislunar, which is important to our country other than NASA, and to be on the way of moon to Mars. And I think we've got that wrapped up with a bow, and I think it's on its way. And I'm optimistic about NASA in the future. And that's why I called to congratulate and to ask Jared to come on by when he can get to D.C., and we'll talk further.
But I'd just like to add, we put a lot of effort in program management and acquisition rigor. But I think if there was one thing that we did that will help the most, it's the Moon to Mars Program Office. There were a lot of disconnects in this highly integrated schedule that were real challenges to work. And I just have to give kudos to Kathy Koerner, who is maybe speechless today, but she's been very important in bringing the team together. And if anybody has any doubt about having picked the right guy for the head of the Moon to Mars Program Office and his technical ability to integrate across all these very complex parameters, I think you don't have any doubt after hearing him today. I think those things have and will continue to make a lasting difference in program performance. And so I agree with you, Bill. I think we're handing over an agency that is well prepared to pick up the pace.
We'll go over on this side. Sorry, in the back.
Hi, thank you. Nick Alexander with Space Scout and the Space Policy Institute. Administrator Nelson, you've emphasized the importance of getting to the moon before China, that this is an incredibly global environment now, and it's a multipolar environment. You know, in the event that, you know, we don't get there before China, what sort of rules and norms would we be setting kind of post-landing, you know, and could you also talk about what the rules and norms that you'd like to set prior to a landing with prior to a Chinese landing? Thank you.
Well, I have answered this question many times in the past, that it's important in an area where we think there is such promise, the South Pole, primarily because of the presence of water, that we establish our presence there so that China would not be there and say, keep out. Now, why do I say that? Well, you can usually tell about where a fellow's going by virtue of where he's been. And the history, the political history, the defense history of China, we have seen what they've done in the South China Sea with the Spratly Islands, most recently taking a sand spit of an island that is within the 200-mile range of the Philippines and suddenly claiming that's not the Philippines, that's China's territory, building it into a runway for military and a harbor for military. And so I wish it weren't that way. I wish that China could be someone that we could cooperate with, and maybe there will be an opportunity in the future. I hope so. But given the fact of the history of how the Chinese government has operated up until including recently, I don't want that to occur on a very important part of the moon. Now, at this point, we don't have any indication that their first human landing, which they say is 2030, is in fact the South Pole. It may be what we did over 50 years ago the equatorial portion. That is to be seen. But clearly they are wanting to establish something there in what they call their International Research Station.
I'm going to go back to the phones for a few more because we do have a number of people on the line. Michael Sheets from CNBC.
Hi, all. This is Michael Sheets of CNBC. This question, I believe, Nelson, Administrator Nelson, I'd appreciate an answer on this, but others can jump in if they'd like to as well. The first uncrewed launch of the SLS rocket was 6 years behind schedule. We're now looking at a 4-year gap before the second launch. You talked a little bit about having a regular flight cadence, but launching not even every year, but launching every 4+ years doesn't give a lot of confidence that you're going to be able to launch Artemis III a year after Artemis II. How do you continue to sort of justify where that change in that closing that gap between the launches is going to come from when you're looking for billions of dollars in continued congressional appropriations for this program moving forward?
Yes, so this is Jim Free. I'll give that a shot. I think what we've highlighted here is just one piece of the learning we've done from Artemis I to Artemis II. And as I say, heat shield's one of those. We learned a lot about the vehicle performance. We learned a lot about things that happened on the service module and the crew module. We obviously would like that time to be shorter. I think some of the things that, you've heard about manufacturing is important. We need to do better on our delivery. We're understanding the vehicle better. We have multiple vehicles in flow. I talked about Artemis III, the environmental control life support system we found there, informing 2. That put some delay in our schedule, some of the electronic design that we learned about. So from our perspective, I respect what you're saying about our appropriations. From our perspective, our job is to get better. 6 years to 1, 4 years to 2. The confidence, the proof is in the pudding on the time from 2 to 3. We learned, the other thing I'll mention in exploration ground systems, we learned after 1 the damage to the pad that we didn't expect. So we've implemented changes in our design of the Mobile Launcher 1, which now is on Mobile Launcher 2 as well. We've incorporated that design there, those design improvements. So each time we are feeding back the design. Every vehicle that's in flow at the same time, we're feeding back into the design and manufacturing as well. So that 2 to 3 period, our plan is that 12 to 15 months. But we have to prove that, but our goal right now is getting to a safe return of Reid and his crew on 2, and then pushing our way onto 3.
We'll go to Lauren Grush from Bloomberg.
Hi, thank you so much for taking my question. This is for Bill or for Pam. I just want to go back to the incoming potential administrator, Jared Isaacman. He's shared plenty of criticism of aspects of the Artemis program online. Are there concerns about the incoming administration team attempting to completely restructure the program? And what would you say to the new administrator if he is considering spearheading major cancellations of various programs within Artemis, particularly the cost-plus contracts? Thanks.
I have not been concerned. What your question is are they going to axe the Artemis and insert the Starship? And first of all, there is one human-rated spacecraft that is flying and that has already flown beyond the moon farther than any other human-rated spacecraft. And that's the SLS combined with Orion. Secondly, this is a partnership. It's a commercial partnership. It's an international partnership. And by the way, back on your question on China, another indication there is the Artemis Accords. We're right at 50 nations having joined in the Artemis Accords, which is a common sense declaration of the peaceful uses of space. And I think what is going to happen over time is you're going to have a number of years that we're going to have the partners flying with NASA. And then whatever the technologies that are developed later on, that will dictate what is going to be the system that's flying. But in the immediate, we're going to have SpaceX flying for lander on the Artemis 3. Artemis 4 is going to be SpaceX, and Artemis 5 is going to be Blue Origin. And so I expect that this is going to continue, and I don't see the concern that your question raises, although it's a legitimate question, that you're suddenly going to have Starship take over everything.
We're going to take one last question from the phones, and then we'll come back to the room. So I'd like to turn it over to Philip Sloss from NASAspaceflight.com.
Thank you. I assume this is for Amit. Can you give us a little bit of an outline about the stacking schedule for SLS until Orion is ready for Artemis II? And also there was a tanking test decision out there. And then also in terms of the trajectory change to the reentry, how does that affect the launch availability for Artemis II? Thanks.
Okay, great question. As I mentioned, we got aft assemblies done. So as soon as we walked out of the Administrator's Executive Council today, we gave direction to the team at EGS to start moving the aft center segments over. So that'll start essentially tomorrow. The core stage is in the transfer aisle. It is processed. It shipped, as I said, back in July. We've done everything we can in the transfer aisle. We had built a new fixturing in High Bay 2. So we're going to do the lift on core stage 2 on the 10th, put it over in High Bay 2, and then start working on some of the closeouts and the applications there that we need to do. And then at that point, we're just going to go after the boosters. It's going to be all boosters probably for the next month or so, maybe a little bit longer, until we start getting that close, and then we'll push with the lift. So I think 3 to 4 months we can get the entire integrated vehicle up. That's again going to depend on making sure that we have the learning from Artemis 1. Some of that's challenging just because the teams have turned over, but we've got a lot of those lessons incorporated. So I'm optimistic the team over there is ready to roll. I think the next question was on entry trajectories, overall timeline for the entry trajectory, what that's going to look like. Can you repeat the question one more time? Because I'm sorry, I want to make sure I get it right.
No problem. It was about how the change in the reentry trajectory would change your launch availability and your launch periods and the calendar for that.
Yeah, good. So in order to constrain yourself to 1775, you basically lose the tails of every launch window. Recall during Artemis 1 we had kind of repeating interval every 12 days, or every 12 days we had a 12-day window open. That's just strictly planetary geometry driven. If you at the front tails, back tails, you have to expose yourself to durations you don't want. So we're about 50% of the window is cut out, and then we have to overlay the other constraints. A lot of those constraints we're gonna push back on the same things we did during Artemis 1. We have a couple of launch azimuth and comm constraints that we can work on, but fundamentally 50%. Now that's going to make it hard to launch the vehicle. Incorporating the crew into the loading sequence also makes that we got to be really careful about that. We have a lot of data about crew time on back and how to make sure we mitigate that while we're loading these types of cryogens, and so that's something we understand. But at some level, even though it's a tighter window, a little bit more difficult to handle. Actually, think it's a good challenge for the team because, as before, getting our launch probability up, getting to a point where we can do dual launch, and we can hit an HLS that's in a particular orbit and do that kind of concurrent rendezvous is going to be, it's super important to us to get that capability. So I want us to accept the challenge of, even though it's a tighter window, let's make sure we can hit it, and we're going to practice it. I think there was a question also in there about tanking test. There is a configuration depending on when the spacecraft is delivered over to the ground systems program from the Lockheed Industrial Zone, where we could roll kind of a shortened version of the stack to the pad. Again, we did a lot of checkouts of the mobile launcher while it was at Pad B, flowing hydrogen from the new assets that we have. So we know that up to the pad itself, we're pretty good. But there's nothing like putting the ML and the core stage and potentially even the ICPS in communication with the cryogenic systems ahead of time. So if it turns out we have a little bit more time to process the vehicle and the stack is ready, I think it's the right thing to do to get the stack out to Pad B and tank up. We get a lot of operational experience that way. We'll have a lot of confidence in the sealing surfaces, and then we can roll back, accept Orion, and go back out again. The other thing we did between Artemis 1 and 2 is, you recall, we had a lot of discussion about FTS batteries and the clocks that are started there. As one of the learnings from Artemis 1, we've developed a contingency pad access capability where we can recycle and reset those flight termination systems clocks while at the pad, don't have to roll back. And then also we can do, for example, engine section work and a handful of other things. So our endurance at the pad will be better as well to increase that launch capability.
All right, we have time for just a couple more in the room, but let's go right here in front.
Hi, David Smith of The Guardian. Just a question for Administrator Nelson. Just interested in your thoughts on Elon Musk and his prominent role in the upcoming administration. On the one hand, are you expecting positive benefits in terms of accelerating goals for the moon and even Mars? Or on the other, do you worry that his Department of Government Efficiency could affect NASA with cutbacks, and are there potential conflicts of interest?
Well, understand that I am an optimist by nature, but in this particular case, I think that the relationship between Elon Musk and the president-elect is going to be a benefit to making sure that the funding for NASA is there. So I see that as a positive. Now, to what degree, I just can't speculate on his DOGE effort of cutting throughout the government. I can't speculate on that. But I also know that Elon Musk, as I have said many times to the question, am I concerned about his political activities? Elon Musk has given the authority to run SpaceX to Gwynne Shotwell. And she has been excellent. And of course, the proof's in the pudding. Look what they've done with commercial crew and commercial cargo to and from the International Space Station. So I have every reason to think that that relationship will continue, that her operation of SpaceX will continue as it has been. So I'm basically optimistic about the future for NASA under the new administration.
We'll go up front row on the left. Thanks.
Hi, this is perhaps for Amit, but yeah, with regards to the heat shield, just as in terms of lay people's understanding, it's sometimes hard to understand that this could be done 50 years ago and it's causing such a problem now. How does the damage or the erosion observed on the Orion heat shield compare to what was experienced with the Apollo Command Module's heat shield? And are there any specific design insights that you can sort of glean from that? And for Administrator Nelson, just following up from my colleague a moment ago, obviously, you've spoken warmly about Jared Isaacman, and you've congratulated him, and obviously he brings a lot of qualities to the job. But are you at all concerned about potential for conflicts of interest, given his significant ties and investment with SpaceX, and the fact that he's publicly spoken out against having dual sourcing for the lunar lander systems? Thank you.
Okay, well, let me answer your second question first. We have contracts with 2 companies for landers. As long as we're a nation of the rule of law.
One thing Apollo did differently and continued to do was they recognized that this spallation phenomenon was important. They also recognized that if you lost that material, which they did, I don't have the exact corporate memory, but even during Mercury Gemini 2, that this is something they were worried about. What they did to arrest that problem during Apollo is they, instead of using the block geometry that we have on Orion, they used a honeycomb material over the carrier structure on the heat shield. And so that honeycomb, it essentially was a titanium honeycomb, and that basically provided mechanical separation between the different parts of the ablative material. So you could crack and you could spall, but it wouldn't propagate across the acreage. The formulation of that and the manufacturing of that was extremely tedious. It took a lot of very kind of highly skilled, very sort of minute labor, and but Apollo had an industrial base. The country had an industrial base that could do that kind of work. We tried to do that on EFT-1. That's exactly the formulation we did. But because of the changes in the material and also because of the size of the Orion acreage, it turns out that the way the structure was flexing and all sorts of other things just made that application process extremely difficult. So they were able to do it for EFT-1, but after that they decided it's too challenging. Let's see if we can use the advanced analytical techniques and other things we've developed since then to go to an easier manufacturing geometry, but then let's go work on what that looks like in terms of its interaction with the environment. So that is kind of the traceability from Apollo to today.
We have time for one last question. So we'll do in the middle, in the back row.
Hi, Michael Greshko, Scientific American. Thank you all very much for being here and answering all of our questions. This is a question, I think, for Amit and Reid. Amit, you said in some of your comments earlier that you were exploring ways to make Artemis II a more robust mission and to pull some of the objectives forward ahead of Artemis III. I think, Administrator Nelson, you hinted at some of this with proximity operations. Could you elaborate on some of the options you're exploring to make Artemis II more robust and to, I guess, make the subtext text? Are you all exploring including proximity operations with between Starship and Orion for Artemis II? And to include Reid in this, what does kind of an expanded scope of the Artemis II mission mean for you and your crew as you all train for the next 18 months?
Yeah, so this to me, the first thing we would try for sure, because, and again, we need to do a lot of work with our friends at SpaceX to see kind of what the art of the possible is here. But for me, the biggest bang for the buck will be to get both vehicles uphill at some point in the same interval. That's super important. Whether we can steer them close to each other, depending on the orbital constraints, et cetera, depending on a lot of other different things, that might be challenging. I want to mitigate that challenge by also developing ground test capability. So if we're worried about, for example, software interaction or the radio frequency link between the two, or all those sorts of things that you get worried about when you fly close to another vehicle, I would love to test that on the ground as much as I can. But if we can get just a few ideas. If Starship can be in an Earth orbit, if Orion, if it can be in a lunar orbit, we could even do parallel circumlunar flight. Those are all possibilities, but we need to go, think really hard about what that looks like. But again, to pull some of that forward, even the exercise of choreographing that having the comm there, having all of that fit together would be, I think incredibly useful. Now, to be clear, we are planning on doing that already, and we have to do that for Artemis III. So, this is not new work. So I'm not worried that, for example, there's going to be a lot of discussion about this is some unusual, decision to engage in this. I just want to try and get as much of that done as quickly as possible. And the more we bring and start exploiting the capability that they're building over there as fast as we can, the better we can do it. Now, it's super important to recognize that normally, in order for us to do these sorts of operations, we would want to insert in some kind of stable orbit and do a lot of different checkouts, et cetera. That we're not doing that for Artemis II. The spacecraft is a circumlunar free return vehicle. We have got to keep it that way in order to make sure that we're respecting the constraints we developed in order to mitigate this issue. But other than that, I think just bringing the teams together, even operationally, all of that is a huge value, and we would start with that. But again, that's something I think we should come back and talk about once we have a better plan. But right now, really what I'm trying to communicate is we need to think of every option we can to bring those objectives in to maximize the success of Artemis III. I mean, the approach we've taken here, in big chunks, is not to just look at the next mission in front of us. It's to look at the end, with the end in mind. What is that end objective? And getting the learning done as fast as we can. We talk a lot about, you guys have all pulled on different schedule constraints and things we're worried about, locally with particular valves or particular subsystems. For us, the biggest mistake that I've seen is we end up becoming focused on what we believe is a critical path item, what we believe is, this thing is definitely going to be the one that causes us to be delayed. In my experience, I think a lot of us that have done this before, the pacing item in a test activity this complicated is the unknown. The unknown is what is pacing us. So the more we learn, it doesn't matter how we do it, the more we're going to get the confidence that the mission's going to be successful. And I'll hand back to Tano.
Thanks, Amit. Amit and I talk about this topic all the time. We always want to look for ways to exploit new technology, new capabilities that even 5 years ago seemed like they were a bit out of reach, that are now in reach. So we are lockstep on that. From the crew perspective, I think I'll just say three quick things. First, every single day that this crew comes to work, we are focused on a successful Artemis II, 3 good mains. That is what we want. We want a splashdown off the California coast successfully, but we talk about what is success for us, and it is enabling Artemis III. And that allows us to come in every day and look beyond Artemis II. What are we doing today to help enable humans on the moon? That is what we all want. We will cheer louder than anybody when our friends are walking on the moon, of course. So that is a huge focus for us. The second thing I wanted to say is each one of the 6 of us, myself, Victor, Christina, Jeremy, and Jenny and Andre, we all have batons, like relay race batons, metal batons sitting on each of our desks. And they are there as a symbol of that, of coming back from Artemis II and handing those batons to Artemis III and saying, it's your turn, go. And then we want 3 to come back and continue that tradition. So it really is at the front of our brains. And then the last thing I'll say is kind of a joke, and Pam will definitely get this, but you're going to ask an astronaut to do more on their mission? Bring it on. That is what we live for. We are ready.
All right, thank you all. Thank you for joining us today. Stay tuned for more information on NASA's Artemis campaign at nasa.gov/Artemis, and have a great afternoon. Thank you.